Good morning, everyone. In the last class, we are discussing about the informed search algorithms along with the heuristic function. And already discussed, there are two important algorithms that comes under informed search. That is, one is greedy best first search algorithm and another one is A star algorithm. So today in this session, let us discuss what is this best first search algorithm. It is also called as the greedy search. Greedy best first algorithm always selects the path which appears best at that moment. That is, it is a combination of DFS and best first search algorithms. It uses the heuristic function and the search. So with the help of this best first search, at each step, we can choose the most promising node. And in this algorithm, we expand the node which is closest to the goal node, and the closest cost is estimated by the heuristic function. That is, f of n is equal to h of n, where h of n is equal to estimated cost from node n to the goal. So this is the best first search algorithm. Already told you that it is a informed search algorithm and it uses the make use of heuristic function. So this is the algorithm. First, open. Let open be a priority queue containing the initial state. So what do you mean by this priority queue? Priority means in terms of heuristic values. So whichever heuristic value is having less, that is going to be placed in the priority queue. Then let us start the loop. And if open is empty, return failure. Or else if open, remove first open node, and if node itself is a goal, then return the path from initial to node. Or else generate all successors of node and put the newly generated node into the open list according to their F values, that is heuristic values. And then we can end the loop. So let us discuss this algorithm with the help of one example. Until and unless we didn't solve one example, you can't understand this. What is this algorithm? So let us see one example. So this is the given graph. You see here, let A is the start state and G is the goal state. And here you can see these are the heuristic values. So A to G, remember for any example, for any graph, we will be having the heuristic values and the cost from one node to other node also will be given. And accordingly, we are going to find out the cost of from start state to goal state, either using best first search algorithms or the A star algorithms. So here, how they have calculated this is straight line distance. We already discussed in the last class. One is Euclidean distance, that is x2 minus x1 whole square plus y2 minus 1 y1 whole square root. In that way, they have found the distance between two nodes. That is from A2 to reach to goal node, this is the heuristic value. From B to G, this is the heuristic value. C to G, this is the heuristic value. Likewise, from A to G and to reach G to G, obviously it will be 0. Now, as per this algorithm, okay, let us solve this particular example and what is the best path that greedy best first algorithm is going to give. See here, the very first statement is let open be a priority queue. So, as per this diagram, our start node is A. So, let us start with node A. Yes, if it is empty, the algorithm is saying return failure. But when we open A, this is not an empty. It is giving us three nodes. When you expand node A, it is giving us three nodes. So see in this diagram. So when you explore or expand node A, we are going to three nodes. That is B, C, D. That is B, C, D. Now, and if node is the goal node, okay, then return the path from initial node to the goal node. But any of this is not a goal node. So else we have to generate all successor of node and we are going to put the newly generated node into open according to their heuristic values. Now first, let us find out the heuristic values of these B, C, D. So B will reach to goal state, C will reach to goal state, and D will reach to goal state. But out of these three, which path we are going to select? So when you see here, B to G, the value is 32, and from C to G, it is 25, and D to G, it is 35. D to G, it is 35. Now, out of these, okay, we are going to generate the node according to their F values. Now, out of these, we know that C is having the least heuristic value. Okay, so now we are going to explore the C node. So, as per this diagram, when you explore C node, it is going to E, it is going to F, and even it is going to A also. We can write, or we can also not to write this one, but let us define. So it is C to E, C to F. If you want, you can also say that it is C to A, but it's already closed, so we need not to write. Okay. Now let us see the heuristic values from E to G, F to G. So E to G is 19, F to G is 17. So it is 19, it is 17. So obviously, as per the algorithm, now we are going to explore F. And when you explore the node F, yes, it's directly going to the goal state. So we can end the loop. So now F to G, and the heuristic value is obviously 0. Here the heuristic is 0, and it itself is the goal node. So we are going to if node is a goal node, see here, see the algorithm. If node is a goal, then return the path from initial to the node. That is initial to the, so this is the, so what is a greedy best first search has algorithm? The given path is A to C, C to F, F to G. So in this way, we are going to find out the best path using this greedy best first search algorithm. In another way, how to write the steps of this greedy best first search is, where in the very starting node, we are going to open A, and when you expand A, it is going to open then B, C, D, then this opened one is going to be into the closed list. And in this, we are going to explore the C node. Okay. Now, when you explore C node, then the open node will be BD. And when you explore C, we are going to get it as E comma F. And in closed node, what we are going to have? A comma C. Next, we are going to explore the F node. Then the open list will become BDF, and closed list will become A, C, F. And when you open this F, what we are going to get? B, D, E, G, and the closed list will be the same, A, C, F. Now the next is the goal node. Then the goal node will go to the closed list, and in open list we are going to have BDE, and the closed list consists of A, C, E, F. So whatever the values of the closed list, that is the required path. So in this way also we can find out the path using this greedy best first search algorithm. Then what is this? What are the advantages, or why we have to use this greedy best search is, there are some important point. Yes, it gives us the good solution. One important point regarding this greedy best first search is, it gives good solution, but it does not guarantee that it is going to give the optimal solution. Okay, why? Why it is not giving us the optimal solution? Let us see this here. Our path is A, C, F, G as per the heuristic values. But when you see the path cost, you see here 14 plus 10, 24 plus 14 plus 10, 24 plus 20, it is 44. Suppose if we travel in this way, A to C, E, H, G, what is the cost? 14 plus 8, 22, 22 plus 31 plus 10, 41. Means if you see the path cost, this 41 is the least value, but whereas when you see follow heuristic values, this is getting the highest value. So this is one of the disadvantage of this greedy best first search algorithm. So means it is giving good solution, but this is not the optimal solution. So to overcome this disadvantage, we are going to use other algorithm, that is A star algorithm, one of the informed heuristic search algorithm. So what is the new thing in that A star algorithm is, along with the heuristic value, it also takes into consideration of this path cost. So total, it is going to take the path cost plus heuristic. So in that way, A star algorithm will give us the optimal solution, which is a disadvantage of this greedy best first search algorithm. Thank you.